Today's episode of the Cloudcast is sponsored by Datadog. Bring speed and scale to your security organization. Datadog Cloud Security Platform delivers real-time threat detection and continuous configuration audits across applications, hosts, containers, and cloud infrastructure. Built on top of the observability platform, Datadog brings unprecedented integration between security and DevOps aligned to shared organizational goals. As a listener to the Cloudcast, you can sign up for a free 2-week trial to see for yourself how Datadog can elevate your cloud infrastructure security posture by visiting datadog.com/security-cloudcast. Sign up now and receive a free Datadog t-shirt. That's datadog.com/security-cloudcast.
Cloudcast Media presents from the massive studios in Raleigh, North Carolina. This is the Cloudcast with Aaron Delp and Brian Gracely, bringing you the best of cloud computing from around the world.
Good morning, good evening, wherever you are, and welcome back to the Cloudcast. We're coming to you live from our massive Cloudcast studios here in Raleigh, North Carolina. And as I hit record on this, it is the end of July. And if you are in the Northern Hemisphere, it's hot. It's really hot. So for everyone out there, please, please, please stay cool, stay safe. We hope everyone is enjoying the summer. Now, we have some really good cloud news this week, and we're going to go ahead and jump right in for our first article this week. Gartner has a new Magic Quadrant out. It is the Public Cloud IT Transformation Services. Now, it's a bit of a mouthful for a name, without a doubt, but an accurate description and certainly an emerging area for a lot of organizations. Makes perfect sense, actually. So let's go through it real quick. The folks over at Atos were nice enough to post it out on Twitter, so I'm assuming they licensed it. While we don't have access to the full report, it's good to see the quadrant. So in the leaders, it is Deloitte, HCL, Accenture, Capgemini, and TCS. No surprise to anyone probably who knows this space. I mean, those are all the big integrators that are out there. Makes perfect sense. Challengers, Infosys, IBM, Wipro, Cognizant. Again, probably makes sense as well. Without going into the details on it too much more, Atos is in the visionaries. NTT Data is in the visionaries. If this is of interest to you, we do have a link to the quadrant in the Cloud News of the Week. Go take a look. And if I move on to our second news item of the week, Microsoft came out or will be coming out with video stories to Teams. Now, I completely admit I don't use Teams more than I have to. No offense to Microsoft, but I do know more and more folks are using it, especially big enterprises, and they want to make it maybe a little more. At first, I thought, oh, they're going to make it social, but it's less about that. Think of it this way: an internal use case where maybe there is a sales leader or a marketing leader or an engineering leader, and they want to put out a quick status update. And with things going more along the way of feeds and Snapchat or Instagram or TikTok, what is a visual way to put a quick snippet into a feed that your organization can go look at? Now, this has been tried many times before, the whole idea of an internal news feed that is for the enterprise. But building it into Teams does make sense, and building it into as a small video platform certainly makes sense as well. So hopefully we will be seeing this at some point here in the near future, and whether or not it will be successful or not is still to be determined. Moving on to our third article. And actually, this is less of an article as much as it is just a pretty amazing resource. Freefor.dev, and again, link in the show notes, but it is a massive list of all the free tiers that are out there for developers. So if you're looking for service providers, if you're looking for DNS, if you're looking for email, if you're looking for IDE, database as a service, I mean, it just goes on and on and on. And this is been compiled by over 1,000 people, and you can just do a pull request. And so it is tracked and it is out there. And it, like I said, it is just a massive list, and it's a pretty amazing resource. So definitely go check that out. And that is free-for.dev. With that, I'm going to close out Cloud News of the Week. Coming up right after the break, we have the folks over at Temporal IO talking about managing microservices.
Today's show is sponsored by Lightstep Incident Response, built on the ServiceNow platform used by over 6,000 companies worldwide. Lightstep Incident Response allows you to scale your incident response team without adding to your monthly bill. With intelligent on-call scheduling and escalations, you get the full context of your service health. Lightstep Incident Response immediately pinpoints issues and uses machine learning to send group text, reducing your time to respond. And you can seamlessly orchestrate alert and incident triage with on-call scheduling across Slack, Teams, Zoom, desktop, and mobile. So get started today with a free 30-day trial of Lightstep Incident Response by visiting lightstep.com/cloudcast. That's lightstep.com/cloudcast. And get a free t-shirt after your first alert or incident. And we're back. And folks, obviously, if you follow the show for a while, you know that one of the topics that we've been covering for a number of years, especially as technology has evolved, demands of the business have evolved, is really how do we better build applications, deploy applications, and especially, as we're building more and more microservices applications in different ways, in different languages, there is obviously a benefit that comes from that for the development team, productivity for themselves, the ability to make changes. But on the back end, things can be a little bit complicated. When you've got distributed applications, you've got a lot of moving parts. Trying to coordinate those and do them well sometimes can be difficult. And so we're always looking for, to talk to people who are looking to solve this problem, looking to make it easier to do that. And today we're going to dig into that. So excited to have Maxim Fateev, who is co-founder and CEO of Temporal. Maxim, welcome to the show. Great to have you on.
Well, thanks a lot for inviting me. I'm really happy to talk about Temporal.
Yeah, no, that's great. Before we dive into Temporal, give us a little bit of your background, because you've got quite a rich engineering background and as a leader. But tell us a little bit about your background and then what ultimately led you to start and lead Temporal.
I'm born in Russia, and I have a physics degree from Moscow State University. But then I moved to Brazil, and I have computer science degree from Federal University of Rio de Janeiro, UFRJ. Mm-hmm. So I speak Russian, Portuguese, and English. And then I moved to the US, and I worked for a startup there in Seattle area. But in 2002, I joined Amazon, and it was a relatively small company back then. I think under 800 people. Yeah. And I kind of grew with Amazon. I spent a total 8.5 years there. And I witnessed creation of the whole service-oriented architecture. Amazon transitioned from one huge monolith, so you actually could compile the whole Amazon website as a single binary, and then and run it on your desktop as a Apache module, down to this huge distributed architecture. And I was kind of part of the platform team which owned all asynchronous communication, and I was a tech lead for the team which built a distributed queuing system, which later was adopted by the Simple Queue service, AWS Simple Queue service as a backend. And then I learned that it's very, very hard to build services using queues. Besides, I was the guy who was implementing queues for the whole Amazon. Yeah. And then our team realized that we need a better solution. And out of that, the Simple Workflow service, AWS Simple Workflow service, was born. I was tech lead for the public release of that service. And later, when I moved to Google, and from Google, I moved to Uber. And at Uber, we actually had the similar problem to orchestrate multiple microservices. And I and my co-founder, Samar, we built a system which kind of resembled the ideas, took ideas from the Simple Workflow service, but it was completely different implementation and completely different software stack. And it was built as an open source project. And later we left Uber because this open source project started to pick up adoption, and we started the company. So Temporal is an open source project, MIT license, so you don't have to pay us to use it. And a lot of companies are using that in production right now. But we also create a hosted offering, which is the way we monetize that open source.
Gotcha. Yeah, you've seen some things. We talk a lot about how Amazon is sort of the first and best customer for Amazon Web Services. You were doing that before Amazon Web Services even got started. So that's a pretty amazing career, and I'm sure you've seen some very, very difficult problems to solve, which is great background for what we're doing today. We're going to talk about Temporal. Ultimately, you guys are focused on making it easier to build applications and run them. There's a lot of ways to do that today. There's low code options, there's serverless options, there's platform as a service. How do you look at what was out there and available and sort of said, hey, maybe that's not good enough or it doesn't solve enough problems? How did you think about what was out there and available versus what you ultimately decided to build?
So one thing to mention is that if you look at the last 20 years, a lot of effort went into the operations and deployment.
Yep.
Because we had just bare metal machines, then we've got virtual machines, then we've got Docker, now we have Kubernetes, functions, and all sort of similar things. But at the end, they're all about how you deploy your code and how you operate your code. So it allows to run in at larger scale and having more independent services and operate them reliably. But the thing is that actually the abstractions that developers use to build the applications are still the same. So before, when you had just monolithic applications, you use the database and you would have use SQL or some other framework to talk to the database. You would expose some APIs, so you would have callbacks to those APIs. And if you need to do some background jobs, you would either use cron, or you will pull the database, or you would use subqueue. And these abstractions are still the same 20 years later. And the one thing which changed that services don't have a single shared database, so you cannot use transactions to, and nobody uses two-phase commits at large scale right now, transactions across services. So every service has its own storage, and they're not transactional. And this is the problem, because right now you kind of lose all this beauty of database transactions. And Temporal is an attempt to kind of solve that problem. The way we solve it is interesting. We practically give you a new abstraction, which I don't think existed in this clear form before. We practically say, we give you a piece of code, let's say just a function, and this function is guaranteed to execute. So we provide function which is guaranteed to complete in the presence of various types of failures. So any processes can crash, services can go down, network events, intermittent problems, and then this function still will complete its execution. So it means that the code, and it includes all these stack traces, variables, local variables, and so on. So this is a relatively simple abstraction. And obviously, you cannot run this code on a single machine and tie it to a single machine, because machine can go down. So you need to kind of live migrate this code to different machine. Also, as code can take a long time to execute, you can do something like sleep for 30 days inside of this code. You should be able to passivate that, and it should wait until 30 days until keep executing again. So that is pretty simple abstraction, but then it has a lot of implications. For example, you can make an API call which takes 3 days. Why can an API call take 3 days? Because it can be just some downstream services down. You need to keep retrying for 3 days. So downstream system will keep retrying for 3 days, and you're just blocking the API call. So you just stay there. Or you can have business logic. You say, do something once a month. So you will have a loop, and you will sleep 30 days, then perform some action. Sleep 30 days, perform some action. So that is kind of what you can do with temporal model. And also it allows you to have this consistency across services, because as functions guaranteed to execute, you have hard guarantee that you will be able to complete at the end of the execution, all necessary operations are executed. Or if it's not possible for business reasons, you can execute all necessary compensations. I will stop there because I can keep talking about it for a long time.
Yeah, no, it sounds to me like, at least the way that you explained it, it sounds to me like very much as if, a lot of the ways the abstractions that were available to developers in the past were very, very computer science based. They assumed the system was going to do certain things and it was going to have certain repetition to it. And it feels like what you're building is much more, it's sort of dealing with the vagaries of business. Like you said, you may have some things that, happen once a month. You may have other things that just, are necessary to do, but they're blocked at the time. I mean, it feels like the thought process behind it is much more almost in the context of what business could do or business possibilities, and less kind of restricted by these sort of, fixed things that you might only think about it from a computer science perspective. Is there some truth to that?
Yeah, I think this is a very good way to put it, because what I described is your business logic. Because your business is wait 30 days and send email or like charge subscriptions, send email if about that you've been charged, and then check if it was canceled, for example, and do it in a loop. That is the way you describe it. It can be in words, it can be in code, it can be in Java, it can be TypeScript. But this is a few, 10 lines of not very complex code. But then you give this script or code or pseudocode to a developer and say, okay, now I have 200 million subscribers, and I need to run it reliably. And I need to make sure that their subscription is never lost. And then I need to make sure that in presence of any failures, these things will keep executing. And then you practically will, the resembling like system will have nothing to do with the original 15 lines of code. You'll have a bunch of callbacks, you'll have cron jobs, you will have maybe durable timers, you will, the drill. It becomes very complicated. Then if it's large, you need to shard your database and so on and so on. And you practically will assemble that from all these building blocks, as you said, like computer science type blocks, right? And what Temporal does is that internally, if you look at our service, it has all of that. It is a complex, distributed, asynchronous, event-based system which uses event sourcing and so on. But we expose this to the developer. We hide all of this complexity on this very simple model. We have code which is guaranteed to execute.
Okay, so it also seems like, to a certain extent, as you mentioned before, we used to have kind of front end application, sort of middle tier business logic and back end database. It seems like you're kind of breaking those traditional boundaries apart to where you're saying, look, you shouldn't be restricted, to those sort of three building blocks. You should be able to kind of piece things together, like you said, however makes overall sense to either the experience you want or the business logic you want. Is that kind of some of the thinking that's going on?
Yeah, because obviously it doesn't solve every possible use case, sure. But for a very large number of use cases, you don't need to talk to database directly because every field, every value, every local variable in your code is always preserved and durable.
Yep.
So you imagine like the most basic thing, you get a request, you want to calculate some value or maybe increment a counter, and then respond. So in this case, you will just have an object, it will get a request, it will increment local variable, and then respond. And maybe do something if this local variable changed like a certain threshold. So you can do, watch some process and react to that. Or you can have object, for example, airline points. So maybe you store an airline, like you're an airline, and you want to store points inside of that object, and so on. But maybe even more simple, you just do deployment to AWS, and you need to deploy multiple Kubernetes clusters or something. How do you ensure that this process completes and in presence of failures? And this is the very simple way to do that.
Gotcha. Now, one of the concepts that Temporal has is workflows, temporal workflows. Kind of walk us through the mechanics of that. How much of that is, the developers having to think about things differently? Are they still just writing, Java code or whatever the way they would? How much of it is the people that have to manage operations? Like, who's interacting with workflows? How much does it change maybe what you previously had done? Kind of help us understand the concept and who it interacts with.
Yeah, so we use existing terminology. So we use word workflow for this exactly code, which is guaranteed to execute. We don't like that terminology too much because when we usually say workflow, people imagine existing legacy systems and they don't try to even apply them for a lot of use cases, because how many people will apply an existing workflow engine to implement something like airline subscriptions or deployment, deployment to AWS or system which reboots, for example, every machine in your data center and upgrades the kernel. So that's why but we still use that terminology. So the workflow is practically code which performs business logic, and we call it orchestration also, practically tells what to do. But you orchestrate things, and these things are usually modeled as we call activities. And this activity is just any code, practically any function, which can call any external APIs and perform any real work. The idea is that workflows don't call external APIs directly. They're not going to call your service or database. They will always do it through activities. And then you practically move all the actual work into the activities, and workflow orchestrates that and also keeps state necessary to orchestrate them. That is kind of the basic idea. So as a developer, for some Java developer, you just get our SDK, which is just a normal Java library. So you just go to Maven, your Gradle or Maven file, include our library, and then you start coding against our APIs. You write workflows and activities, and then it's pretty straightforward, just normal Java code. And then you deploy that, and you link to your service and you deploy it. Temporal doesn't deal with deployments. It is you run your code, you still run it, it's just still part of your services. Okay. And then to perform all this magic which I described, Temporal needs a service, and service is the same, is more like external services like database, right? So it runs somewhere. It can run in the cloud if you use out a cloud offering, or it runs on your premises somewhere, or it can run in your machine if you are doing local development through Docker Compose, or we have also a single binary implementation. And then this service exposes gRPC interface. And then all your this library needs to initialize is practically just connection string to the gRPC interface. And after that, you can run multiple instances of your service. And then you have separate component which starts those workflows because you need to create instances. And then you will have what we call worker processes, which execute those tasks, activities, and workflows. Interesting. And as you said, roles, like there are developers who write workflows, and there are people who operate the cluster, which can be a separate team, and then and this is it. And then like developers deploy their code using standard mechanisms, whatever they use in their company.
Interesting. I'm sure you get people who have built existing microservices applications or distributed applications. What do you find as you talk to those developers or those companies that they see is different when they're using Temporal? Either something simpler, there's things they don't have to do. Can you help us understand what happens sort of new, or what do you sort of take care of? Right, you said the magic of what happens.
And just their code becomes simpler because you practically end up just focusing on your business logic.
Okay.
And then it's performs this because internally it's an event-driven system, but it's exposed you as just synchronous invocations of operations. And these operations can take any unpredictable amount of time. And these operations can be hosted by other services. So practically you can think Temporal as a other way to look at that is more like service mesh, but service mesh for long-running operations. And, So this you can invoke something, it takes 3 days, but for you it's just normal RPC call which takes 3 days, and you are still blocked on that line of code. So it makes running practically you can take, because think about it this way: if you take normal service mesh is awesome. It's awesome, but for any request which is under a few seconds, right? Because your service gets a request, it calls a bunch of other services to serve that, and then sends a reply. Awesome. But then I say, okay, any of those requests can take 5 hours. What do you do? Then okay, I need to queue now, right? Or I need to do something else. Or I need to create event-driven system. And then I need to do some sort of saga in that, which is complicated. And then I need persistence because I need to maintain state, all of that. And with Temporal, you practically don't need to do anything. It's still almost the same code. You still call this operation. They still block an operation. You still get exception propagation. You practically get all the normal goodies of the kind of synchronous service invocation, but in this fully asynchronous and long-running world.
Got it. And you're doing all those things behind the scenes in your SaaS service.
Exactly.
Gotcha. But I think like you mentioned, it's also an open source project. So in theory, if you set up your own persistent system or some sort of queuing system in the background, you have a way to plug into those things if people run it, say on.
So Temporal doesn't implement its own database. It sits on top of existing databases. So right now, out of the box, Postgres, MySQL, and Cassandra are supported. Queuing, you don't need separate queue. It implements queuing on top of the database you give it. Mm-hmm. So it can implement queues, and it's implements in a very efficient way. So you kind of just start using that, but as an operator, Temporal service itself is just a bunch of stateless processes which talk to a backend database.
Gotcha.
And if you know how to run database, it's again, Temporal doesn't require you any additional persistence, which people don't like custom persistence projects.
Right. Exactly. I would assume, and well, we talked about some use cases. You said, could be airlines points. It could be, is Temporal primarily sort of focused on people building new applications, or do you find that, do people come to you with sort of existing sort of monolithic type applications that they're trying to modernize, and your system helps them? Is it do you target one type of application, or is it pretty broad spectrum?
It is extremely broad spectrum, and even so, you don't need to do service. You can absolutely use Temporal in the monolith, because you still need durable timers. You need still make sure that things execute. You still need to you hold all the same requirements. Mm-hmm. But in the service-oriented world, when you have distributed system, it becomes even more important, because again, you don't have a single database transactions.
Gotcha.
I even asked people, the way people using that even as a desktop application, because it helped them to maintain to perform the state management.
Gotcha.
But the most common one is again is in the world of microservices.
Sure.
It's where people mostly run it.
Right. Makes sense. Makes sense. Well, listen, I've asked a lot. We're going to put some things in the show notes for people so they can dig into the technology. Obviously, there's a lot there. Sometimes it's hard for us to verbalize all of it. If anybody wants to engage with your team, wants to try out Temporal, what are some of the good ways to engage with you, to learn more about how this system can help their applications?
So I would start from our website, temporal.io. Mm-hmm. And there are links to documentation, to tutorials, to our community forum, and we also have Slack channels, a bunch of Slack environment, and There's a bunch of Slack channels. Our community is, I think, we have awesome open source community, very strong. A lot of enterprise users from big companies using us, and I don't want to give you long list of logos here, but you can find them on the website. The interesting part is that all these companies are using us for mission critical applications. We are not talking about, I will do this little thing. Yeah. It's more they're actually using this as part of the core business logic. And I think this is what it makes very interesting open source projects, because not many companies kind of rely their core business on some open source projects, which is relatively new. It's 5 years old.
Right.
Okay, it's 6 now.
Oh, congratulations.
But I think the point is that it's you just start from our website. The only other thing which I want to mention is that we will have our first developer conference on 25th, 26th of August. So go to our website, you can sign up there as well, and it will be so if you want more information. And you can always find me on our Slack or community forums. I'm pretty available.
Okay, well, good. We'll get some links to all that. We'll get links to the developer conference in the show notes as well, so folks who are listening, that'll be easy to find. Well, Maxim, thanks so much for the time. I really enjoyed both learning about your background, the types of problems you solve, but more importantly, where you're going with Temporal and the types of the ability you have to help people build better, more robust distributed applications. So thank you again for the time. Folks, on behalf of Aaron and myself, we want to thank Maxim for the time today. Thanks everybody for listening to the show. Thanks for telling a friend about the show, helping us grow the community. And with that, I'm going to wrap it up, and we will talk to you all next week.
Thank you for listening to The Cloudcast. Please visit thecloudcast.net to find more shows, show notes, videos, and everything social media.